Okay, so we're going to use the law of cosines to solve some more triangles. So this says solve the following triangles. A is 42 meters, B is 51 meters, and C is 73 meters. So we're going to set up A, B, C. Little a, which is 42, little b, which is 51, and little c is 73. So obviously we need to find A, B, and C. And the advice we got in the last video was to find the largest angle first. So our largest angle here would be angle C, the one across from the biggest. So we're going to set up law of sines that says c squared equals a squared plus b squared minus 2ab cosine of c. So we'll have 73 squared equals 42 squared plus 51 squared minus 2 times 42 times 51 cosine of c. Now we want to get cosine of c by itself. So the first thing we need to do is subtract 42 squared and 51 squared from both sides. So 73 squared minus 42 squared minus 51 squared is equal to negative 2 times 42 times 51 cosine of c. And if you don't like writing all this, you can certainly do pieces of this in your calculator. So we can do 73 squared minus 42 squared minus 51 squared. So we get 964 equals, and we can do negative 2 times 42 times 51. And we get negative 4284. So we get 964 over negative 4284 equals cosine of c. So to find c, we need to find cosine inverse of 964 over negative 4284. So cosine inverse of 964 divided by negative 4284. So 103 degrees. Okay, now that we have that, we have an opposite pair. Okay, so we can set up law of sines. We can say 73 over sine of 103 equals, let's find b, 51 over sine of b. We'll cross multiply, so we'll have 73 sine of b equals 51 sine of 103. We'll divide both sides by 73. So we have sine of b equals this stuff. And then we need to take sine inverse. So b is going to be equal to sine inverse of this stuff right here. So we can do sine inverse of 51 sine of 103 divided by 73. So we get 42.9 degrees. Okay, and now we can use the fact that the interior angles add up to 180. So 180 minus 42.9 minus 103 gives us 34.1 degrees. Okay, so that's an example of how we would solve a side, side, side triangle. And we can use these in applications. So this application says, a clump of trees is in the way of measuring the entire length of a property boundary. So two sides of and an angle of a triangle are measured around it. Find the total length of the boundary line. So we want to find this so that we can take 30 plus x plus 43 will be our final answer. The length of the line. So we want to focus on this triangle. And instead of calling that x, let's call that c. And we'll use the law of cosines, that c squared equals a squared plus b squared minus 2ab cosine of c. And it doesn't matter which one you call a and which one you call b. So c squared will equal 16 squared plus 21 squared minus 2 times 16 times 21 times cosine of 80. And to get c, we just want to take the square root of both sides. So c is equal to the square root of 16 squared plus 21 squared minus 2 times 16 times 21 times cosine of 80 degrees. So 16 squared plus 21 squared minus 2 times 16 times 21 times cosine of 80 degrees. So we see that this is about 24 feet if we round to the nearest foot. So to find the length of the boundary line, that'll be 30 plus 24 plus 43. Okay, so the length of this boundary line is about 97 feet total.